Okay, good afternoon. Let's continue from where we left. Significance level of alpha. So remember I said that alpha is the probability of committing type 1 error. So this is the probability of type 1 error. Alpha is the probability used as a standard for rejecting H0 when H0 is true. The value alpha is also known as the size of the critical region. Remember I said critical region is also the rejection region. So that size of the rejection region is the alpha value. By alpha equal to 5%, remember 5% is 0.05. We mean that there are about 5 chances out of 100 of incorrectly rejecting a true H0. In other words, we say that we are 95% confident in making the correct decision. So when given confidence interval C, we know the confidence interval C, then alpha is 1 minus C. So when C is 95%, then alpha will be 1 minus 0.95. 95% is the same as 0.95, which is 0.05. That is just 5%. What if C is given to be 99%? What will be our alpha? Our alpha will be 1 minus 0.99, which is equivalent to 0.01. This is just 1%. When given C to be 90%, then our alpha is 1 minus 0.90, which is 1 minus this is just, that is just 0.1, and this is just the 10%. That will be our alpha. So this significance level is very important because it is going to help us get the critical values, which we are going to read from either the Z table or the T tables. Now, in our next subchapter, we are going to look at one-tailed and two-tailed test. One-tailed and two-tailed test. So basically, there are 3 kinds of problems in test of hypothesis. They include two-tailed test, right-tailed test, left-tailed test. What is a two-tailed test? Two-tailed test is that where the hypothesis about the population mean is rejected for the value of X bar. What is X bar? Sample mean falling into either tail of sampling distribution. E.g., when you have this hypothesis here, H0 mu is equal to 100, then HA mu is not equal to 100. By looking at the alternative hypothesis, which is our research hypothesis, mu is at the center. So when mu is 100, values that are not equal to 100 can be either to your left or they can be either onto your right. For example, 95, they are onto your left. 200, 300, they are onto your right. So you are going to do two-tailed test because the values can be either to the left or to the right. And suppose I'm given alpha to be 5%. Suppose I'm given alpha to be 5%, then this one is a half of 5 and this is a half of 5, so that they add up to 5. So that is why it is 0.025, this area, and this area is also 0.025. The remaining part, which is the acceptance region, will contain 0.95. To the left, you will have the negative Z alpha over 2. To the right, it is positive. When the hypothesis about population is rejected only for the value of X bar falling into one of the tails of the sampling distribution, then it is known as one-tail test. If it is to the right tail, then it is called right-tailed test. E.g., Look at this hypothesis where mu is less or equal to 100, then HA mu will be greater than 100. So if here is where the mu at the center, values that are greater than 100, they are on to your right. So this is the alpha value. If alpha is 5%, don't divide alpha by 2 because it is only falling into one of the tails. So it becomes 0.05. Then the acceptance region will take 0.95. Remember, this is a probability, it must add up to 1. And if it is to the left tail, then we say it is left tail test. E.g., look at this hypothesis here. I want you to look at this hypothesis. H naught mu is greater or equal to 100 grams and HA mu is less than 100 grams. So if here is where you have the mu, remember we are looking at the alternative. Values that are less than 100 will be onto the left of the mu. So I've just worked it on the left side of the sampling distribution. Don't divide mu by 2, is just 0.05 and this is 0.95. And the critical value will be a negative z of alpha. So that is what is all about the one tail and two tail test. Depends with the alternative hypothesis that you have. Okay. Okay, now with this how we are going to get the critical values for different alpha values. So when alpha is 1% and you are performing a two-tailed test, our critical values is a plus or minus 2.58. When alpha value is 5%, our critical values is a plus or minus 1.96. And when you are performing a one-tailed test at 1%, our critical value is plus or minus 2.33. So I will just take one and tell you how I've gotten these values, then the rest you can do. So for example, let me take an alpha value to be 5% and I'm performing two-tail test. I'm performing two-tail test and my alpha value is 5%. So remember our sampling distribution takes the shape of a normal curve. And here is where you have the mu. Since you are performing two-tail test, that means 5% will be there. 0.025, divide that by 5% by 2, you get 0.025. So this part which is remaining, remember the total area should be 1 and mu divides into 2 equal parts. So this is from the left up to the center is 0.5, center up to the right is also 0.5. So when you take 0.55 minus 0.025, you remain 0.475. When you look this value into the normal table 0.475, you realize that it corresponds to a value of 1.96. That's why I've gotten this value. Just look for 0.475, it corresponds to a Z value of 1.96. So try do the rest and you will confirm with me that these are the critical values. Suppose you are using a t-distribution. And you want to find the critical values. Critical values for t. T test. You must have t alpha comma degree of freedom. So the degree of freedom, that is the df, is always n minus 1. So when your sample size is, let's say the sample size is 10, and alpha is given to be 5%, then this is your t-table. The t-table looks like this one. It is everywhere, it is online, you can look at it. So you will just go to the alpha's values are up there. So we go where there is 5%. 5% is here. Then n is 10. So 10 minus 1 is 9. So go to column of 9 and look where there is 5. You'll have a value 2.262. So that will give you 2.262 plus or minus. So that's how we are going to get these critical values. You can read them from Z or you can read them from T. With the T, you need a degree of freedom and the alpha, but here you only need the alpha values. Okay, let's look at the steps we are going to follow when doing the test. Step number 1, you must state the null and alternative hypothesis. You must state them correctly. And please look at the terms used. If they use is, less, greater, at least, at most, you know the sign that takes. Step number 2, choose level of significance alpha. Most of the cases you find that the alpha value is given, and most commonly they use 5%. Step number 3, find the critical values. And these critical values, we read them from the table. And when you read them from the table, we are going to call them the Z tabulated if it comes from the Z table, or T tabulated if it comes from the T table. Step number 4, find the test statistic. The ones we are calculating and where we are calling them the Z calculated or T calculated. Then compare the tabulated values and the calculated values, then draw the conclusion. Remember, in the conclusion, you tell us whether to reject or we fail to reject. Let's take some of the examples. Now let's look at our example 1. The academic registrar in a college claims that most candidates in the college score an average. Remember, the term here is average. Average is mean, of above 50. Above, that means greater or equal to 50 in the final examination. To test his claim, a random sample of 25, they have sampled 25 students, was selected and found to have scored an average of 65% with a standard deviation of 20. Test the registrar's claim at 95% confidence level. So first, summarize the information. Let's look at what we have. We have mu, which is 50%. So that is what the registrar is claiming. Then this 25 is the sample size. And from the 25, the mean is found to be 65. So 65 is the sample mean. And standard deviation is also given to be 20. So we have C, which is 95%. This simply means that what will be your alpha? Your alpha will be 5%. I said that alpha plus C should give you 1. So when C is 95, then alpha is 5. So let's look at the first step. Step number 1. Step number 1, state the null and alternative hypothesis. Since it is average, then our null hypothesis will be mu above, that is above 50%. You can use 0.5 or 50. And once you have the null, then alternative hypothesis will contradict and say now it is less than 50%. Step number 2 is alpha value, we have it to be 5%. Step number 3, you have to look at the critical values. So critical values, we are going to read them from the Z table. By the way, am I going to use the Z table or a T table? And how will you know that? Remember the conditions that we noted down, the condition for T and conditions for Z. So in this question here, I have the sample size less than 30, but the population standard deviation is known. So when the population standard deviation is known, then you have to use the Z test. Even though the sample size is less than 30, but the population standard deviation is known, then you have to use the Z test. If this one was not known, then I have to use the T test. I have to use the T test. So this one, I just have to use the Z test. The Z test. So critical values. Remember, I said look at the HA less than 50. So if here is where you have the 50% or 0.5, values that are less than 0.5 will be onto your left. So I'm performing one tail test to the left. So this value is 0.05. That is the 0.05, the alpha value. And my critical value is negative because it is to the left, negative 1.96. Remember, you will read 0.475. You look for it. The Z corresponding to it is negative 1.96 to the left. So I have my critical value. Critical value is negative 1.96. Step number 4, let's find our test statistics. Remember, then now Z-cal will be X bar minus mu over standard deviation root n. X bar is 65 minus 50 divided by standard deviation 20 root of 25. And this one is 65 minus 50, you have 15 over 20 root 25 is 5. So you have 15 over 4. 15 over 4 is the same as what? 3 points? 15 over 4 class is 3 point what? Let's confirm. 15 divided by 4. 3.75. Now, you have the critical value negative 1.96 and the Z calculator is 3.75. If you look at this 3.75, it will be in the acceptance region. It will be to the right. So, negative 3.75, let's draw our conclusion. Since 3.75 falls in the acceptance region, we will fail to reject the null hypothesis, and conclude that the registrar's claim is true at 5% significance level. Yeah, that is all. That is all about that problem. Remember, just follow the steps that we wrote down. I stated the null and alternative. Alpha value is given to be 5%. Then critical values, it is a one-tail test to the left. So don't divide your alpha by 2, it remains 0.05. And read that value in our Z table. You will find it at negative 1.96. Do the test statistic. X bar minus mu standard deviation root n. X bar 65 minus 50 standard deviation 20 and root 25. And you get 3.75. So this value will fall in the acceptance region. Remember, from here coming this way is acceptance region. This way is rejection region. So if I could have gotten negative 3.75, that will fall in the rejection. I could have rejected the null hypothesis, but this one falls in the acceptance region, so I failed to reject and conclude that the registrar's claim is true at 5% significance level. Let's look at example 2. So we have example 2. A manager at Katu Enterprise claims that customers are served within an average of 30 minutes upon arrival. A random sample of 36 customers was selected and was found to have been served at an average of 25 minutes with a standard deviation of 10 minutes. Trace the manager's claim at 5% level of significance. So let's summarize our data. We have mu. Mu is 30 minutes. What else do we have? We have n. 36 customers. And out of 36, the mean came to be 25 minutes. That is the x bar. And the standard deviation is 10. So, step number 1, state the null and alternative hypothesis. Mu is that, and HA will say mu is not that. Step number 2, we have alpha to be 5%. And step number 3 is to find the critical value. So this will be a two-tailed test. This one will be a two-tailed test. So you have to divide your alpha value by 2, and this will be 0.025. This is also 0.025. Remember here you have the mu, which is 30. So this one will be 0.475. And that will give us minus 1.96 and plus 1.96. Step number 4 is to do the test statistics of Z-calc. I'm going to use Z table because of the conditions there are met for a Z table. X bar minus mu divided by standard deviation root of n. X bar 25. Mu that standard deviation 10 root 36. So this is negative 5 over 10 over 6. So this one will give us negative 3. Negative 3. So by looking at what we have the critical values, this negative 3 will fall in the rejection region. Negative 3 will fall in the rejection region. So since negative 3 falls in the rejection region, the null hypothesis is rejected. The null hypothesis is rejected. The null hypothesis is rejected at 5% significance level. Yeah, it is as easy as that. It is as easy as that. So that is the hypothesis test about the population mean. So let's look at testing hypothesis about the population proportion. And here is the example. A supervisor in a supermarket claims that 20% of the shoppers leave without making a purchase. So that is a proportion. 20 leave, that means 80, at least they buy something in a shop. In a random sample of 80 shoppers selected, it was found that 25 shoppers left without making a purchase. So test the supervisor's claim at 5% significance level. So let's simplify what we have. We have P, which is 20%. There is n, which is 80. And we have 25. So from 25, we can get the p hat. We can get p hat, which is 25 over 80. 25 over 80 is 0.321. 25 over 8 is 0.3. Confirm. 25 over 80. 3125. So that is the p hat. Now, step number 1, state the null and alternative. Step number 1, H naught. P is 0.2 and HA P is not 0.2. Then alpha value we are told to do it at 5%. We are told to do it at 5%. That is step number 2. Step number 3, we want to get the critical values. This is a two-tailed test. So the critical values is just a plus or minus 1.96 when you do it at 5%. Step number 4 is to calculate the z-calc. We said it is p hat minus p over the square root of pq over n. So p hat, we have it 3.125, p 0.2 over the square root of 0.2 times 0.8. Q, I said Q is 1 minus P. 1 minus 0.2 is 0.8 over 80. So when you calculate this value, what do you have? So subtract. Okay. We have 0.0. Now I have 3.125. What do I have now? 0.3125. 0.3125 minus 0.2. 0.3125 minus 0.2. So you will have 0.1125 over 0.2 times 0.8, you have 0.16 divided by 80. Divided by 80, you have 0.02. So what is square root of 0.002? So what is the square root of 0.002? Square root of 0.002. So what will I have? I will have 0.1125 divided by 0.0472. So my final answer will be 0.1125 divided by 0.04472 is approximately 2.5156. That is my Z calculated. So let's look at that value. Is it falling in the acceptance region or rejection region? Remember, my critical value was minus 1.96 all the way to plus 1.96 positive. So this value is outside, so it is in the rejection region. So since 2.5156 falls in the rejection region, the null hypothesis is rejected. This is rejected at 5% significance level. So it is not true that 20% of the shoppers leave without making purchase. That's not true according to our sample data. Thank you very much, and that is the end of test of hypothesis success.